all, my name is Vimal K. Thomas and my friend Romy James P. from S3EC of Christ College of Engineering in Nalagoda would like to present our simple project on logic circuit design subject. The project name is Angular Measurement using Gray Code. This is a device used to measure the angle that the shaft rotated at a fixed point. The components we used for this project is Arduino Uno R3, LCD 16x2, one 250 kilo ohm potentiometer, one 220 ohm resistor, 3 photoresistors, 4 10 kilo ohm resistors, 3 green LEDs and some jumper wires.
First we made a disk as in the figure. For that we used a CD and we make holes in it as given. That is, disk is divided into 8 parts as we have 8 outputs. That is 0 to 45 degree, 45 to 90 degree and up to 315 to 360 degree. Each part is again divided into 3 portions for 3 bits. Each portion is cut according to Gray code from 000, 001 and up to 111, that is 8 combinations from 3 bits. When the value for a portion is 0, we don't cut that portion. But when the value is 1, we cut and remove that portion as the light has to pass through the holes in it. For first combination, that is 000, we don't need to cut any portion from that part. When it is 001, we have to remove third portion from that part and so on. Now the disk is attached to a shaft and we fixed the shaft inside a dark box, and 3 LEDs and 3 LDRs are arranged and fixed as in the figure. 3 LEDs are connected in parallel.
Let me explain the program for Arduino. Hence, the liquidcrystal.h is a library that contains the functions related to LCD 12115432R pin in Arduino that is connected to LCD. Then we declare the variable user in the program. In void setup, we start the LCD using the code lcd.begin 16,2. Here the 16,2 is the columns and rows in the LCD where we can print the characters. We can print 32 characters at the same time. In LCD, using the function pin mode, we can specify the input pins in Arduino. Then we begin the loop. First we take reading from the LDR using the pins 6, 7, 8 of the Arduino. It is assigned to variable XYZ using digital read. And we set the cursor to LCD to 00 and print XYZ. Since the values are in separate form, we have to convert it into a single number. It is saved in a variable G. Then the cursor is changed to 11,0. For output, we use a switch operation. We use 8 cases for 8 outputs. Output is selected as per the value of G.
Let me explain the working of our system. When the circuit is power on, 3 LEDs will be glowing inside the dark box. Dark box is used since other light should not affect the LDR. Let us assume the disk is in the first position. That is, there is no holes in the disk from 0 to 45 degree. So no light passes through disk and no light reaches the LDR. LDR is light dependent resistor. Its resistance is inversely proportional to light falling on it. So when there is no light, the resistance will be high, and when there is light, resistance will be low. In this case, resistance will be high on all LDRs. So 5 volt not reaches the input pins. But since input is connected to ground, that is 0 volt, input is considered as 0 in all pins. After processing, LCD displays Gray code as 000, corresponding binary as 000 and angle rotated as 0 to 45 degree. When the shaft is rotated to next position, that is 45 to 90 degree, there is a hole in third portion. So light reaches to third LDR through the hole. Resistance of LDR will be low and 5 volt reaches to only third input pin, that is 8th pin of Arduino. 5 volt is considered as 1 in Arduino. So we get 001 as inputs in pins and LCD display gray S001 and corresponding binary S001 and angle rotated as 45 to 90 degree. When shaft is again rotated, disc also rotates to next position, that is 90 to 135 degree. There is a hole in second and third portion, so light reaches to second and third LDR through the holes at second and third portion. Now resistance of second and third LDR will be low and 5 volt reaches 7th and 8th pin of Arduino. Hence the inputs in 6th, 7th and 8th pins will be 0, 1, 1. After processing, LCD display gray code S011 and corresponding binary S010 and angle rotated as 90 to 135 degree. As the shaft rotated again, position of disk between LED and LDR changes and LDR gives high value when light falls on it and gives low value to input when no light falls on it. This process continues for all positions of disk. This is how our system works.